Algebra 2. This is the homework for tonight. Starting with number 1. This is this section is pre 6.1. So, question number 1 is when you're multiplying and bases are the same, you add the exponents, that's the product rule. A to the negative n power is 1 over a to the m power. That is the negative exponent rule. Which is this. Number 3, we have a power to power rule. We're going to call that the power rule. And anything to the 0 power, that's your 0 exponent rule. Okay? And now we're going to apply these rules to do these problems. Number 5, if bases are the same, you're going to keep the base the same and you're going to add the exponents. And another name for 4 to the 3rd power is 64. Number 6, x squared times x to the 5th, you're keeping the base the same, you're going to add the exponents. Number 7, you're dividing, so you're going to keep the base the same, and you're going to subtract these exponents, so it would be 3 to the 3rd power, which is 27. Number 8, we've got keeping the base the same, 7 and 4, we're going to have x cubed. Number 9, we're going to flip this and make it 3 over 2, and then we're going to change it to a positive 2, which is really 9/4. We're going to square both of these. The next one, 4 to the negative 2 power is really 1 over 4 squared, which is 1 over 16, and actually negative. You have a negative outside. Number 11, you are going to move these two pieces right here. Those have a negative exponent. So this is going to be a 6 and a z on top, and an x squared on the bottom, and a y cubed. Number 12, 7 goes into 14 2 times. Okay. Now as far as the x's go, you've got 1 x on top and 3 on the bottom, but the 3 on the bottom is going to move up and you're going to make it x to the 4th. You're going to change it to a positive. As far as the y's go, this y comes up on top, you're going to have y cubed. And your z's, this z is going to go on the bottom, you're going to get z to the 7. Number 13, anything to the 0 power, this is 1, so it's 7 times 1, which is 7. Number 14, you've got negative 7 times 1, which is negative 7. Number 15, the whole thing is raised to the 0 power, so that would be a 1. And number 16, this whole thing is raised to the 0 power, so that's 1, and you've got a negative outside, so it's negative 1. Next side. Okay, now we are going to apply some more rules to this. This is a quotient, and the whole thing is cubed. So it's really 5 cubed over x cubed. Cubed is x to the 9th. And now 5 cubed is 125, so you can write 125 over x to the 9th. Number 18, what you could do is we're going to take negative 3 and we are going to raise it to the negative 2 power, and then both of these get distributed. So you're going to raise that to the negative 2 and this to the negative 2. So it's negative 3 to the negative 2 power and y to the negative 4. I'm sorry, x negative 3 to the negative 2, and x to the negative 4, and y to the positive 6, because negative 3 times negative 2 is positive 6. Now you're going to change your negative exponents. This is going to go down, and so is that. So negative 3 squared, it's going to be y to the 6 on top, and these two would go on the bottom. 3 squared is 9, and x to the 4th goes on the bottom. Number 19. What I would do on this one, you can flip the whole thing if you want and make it a positive one, if you want to get rid of that. Or what you could do is simplify what's in here first. I would probably simplify this first. So I make my fraction. 2 goes into 4 2 times. As far as the x goes, you have x squared on top, y cubed on the bottom, and z squared on the bottom. And now we have a negative 1 exponent outside, so you're going to flip the whole thing and make this y cubed z squared over 2x squared. Number 20. I would definitely simplify inside here first and then raise it to the negative 2 power. So I make my fraction bar, and we have 2 over 6, which is 1/3. And these x's, this x squared is going to go up on top, and this is going to go on the bottom. So what's left is 1x on top. This y is going to go up on top, and it's going to become y to the 6th power. And the z on the bottom is going to be z to the 6th power. Now, what you can do is flip this whole thing. So you have 3z to the 6th over x y to the 6th, and then you're going to square the whole thing because you made it a positive 2. So if we square this whole thing, 3 squared is 9, and then we have z to the 12th over x squared y to the 12th. You could flip this whole thing and put this in the bottom and make it a positive 2. And then this goes up on top and makes it a positive 3. Or what you could do is distribute these. Sometimes you'll get positive exponents. So it's up to you how you want to do that. So let's try the 3 to the negative 2. And then we have x, negative 3 times negative 2 is positive, that's an x. X to the 6th power. Negative 3 times negative 2 is positive 6. And y to the negative 4. That's on top. On the bottom, you're going to have negative 4 times negative 3, which is 12. And then we have y to the positive 6. So let's look at our negative exponents. This has to go down in the denominator. So it's going to be 3 squared, which is 9. That's gone. Now as far as the x's go, you have 6 x's on top and 12 on the bottom. So that's going to be x to the 6th left on the bottom. In the y's, I bring these 4 y's down here, and you get y to the 10th, because 6 plus 4 is 10. Next, 22. You can distribute negative 1 to each of these. So it's 2 to the negative 1 power. And then this would be m to the positive 1. Negative 1 times negative 1 is 1. And then you have n to the negative 3 power and p to the positive 2 power. Because a negative 2 times negative 1 is positive 2. All over, 3 squared is 9. M squared. N, negative 2 times 2 is negative 4. And we have p to the 8th. 4 times 2 is 8. Now we're going to simplify this. Make my fraction. This is going to go on the bottom. 2 to the positive 1, which 9 is already there, so that's 18. the m's. We have one m on top and two on the bottom. That gives us one m left on the bottom. The n's are going to flip-flop. You're going to have an n to the fourth on top and n to the third, which is going to give us an n on top, and p to the sixth on the bottom. Because 2 and 8, you have 6 left. Number 23. This 4 to the negative 2 is going to go, this is going to give you 16 on the bottom, and 6 over 8. Now I get a common denominator, which is 16. Multiply this by 2, this by 2. So 3/16 plus 12 16ths is 15/16 is your answer. Number 24, you have 1/4 plus 1/5. Your common denominator is 20. Multiply this by 5 and this by 4, and your answer is 9/20. Okay, for 25, we need to figure out in the bracket, what does this have to be? So what we're going to do is square each of these. And let's see if we can simplify this and figure out what the answer would be. So if you simplify this, you have x to the second power, which this would be x to the fourth. And this is going to be y to the negative 6th power. And then this is going to be x, and then we don't know what this is. We have a bracket, but we have a 2 times that bracket. And then we have y to the 4th power, right here. Okay, now if we simplify this, we have, I'm going to put a piece of paper here so I can work vertically, so you can see this. This is going to come down here, and this is going to be y to the 10th. So this is going to come down here, and you're going to have y to the 10th. And you've got, what could you make this so that when you bring it up here, you're going to end up with x to the 12th. So you've got 2 times something, so you have 4 minus, you're going to subtract these 2 right here. So let's make a little equation. 4 minus 2 times something, we're going to call it x, or you could call it a if you don't want to use x, 2a, because these are the exponents. It has to be a 12. We have to get a 12 here. So now if you subtract 4, you get negative 2a equals 8, and divide by negative 2, so you get negative 4. So we're saying it has to be negative 4. That would be the exponent, because then if you brought it up here and added it to this, you would end up getting that to work. So that would have to be a negative 4. This would have to be a negative 4 for it to work. Okay? And the last problem, you'll do the same way. I would flip-flop these, okay, because you have a negative 1 exponent. And now what you could do, because you're really looking at the x's, that's the only thing you want to, because if you brought this up here, let's do this, bring this up here, you have y to the 5th power. And these two, you're going to bring the z to the 3rd and z to the negative 1, and you're going to end up with z squared here. And we've got x to the 4th here. And we have x to some power here. We'll call it a. So now, all of this is raised to the negative 1 power, which means this whole problem has to be flip-flopped. So in other words, we have x to the 4th on top, and then on the bottom we have x to the some a power, and then y to the 5th and z squared. Well, if we look at what we want here, these are exactly where we want them. So we want to look at these two right here. So the deal is, we're going to take these two and subtract them. So 4, we want to subtract the exponents. We want to set this equal to a 2. How do we get a 2 here? So if we subtract 4, You get negative a equals negative 2, and a would have to be 2. So if this were a 2, the problem would work. And we are done.